Hi people, today we're going to work on 7.3, solving exponential equations, and we're just going to kind of set it up, and then in the future you're going to be able to work through some word problems. This is part of R10, and then the second part of R10 is when we're going to do our next unit, which is logarithmic equations, where we'll be solving stuff within logs, and that'll be R10 as well. So this is just part of R10, what we're doing today. Alrighty, so let's just review some stuff that you have used in the past, probably in grade 11 for sure. When I have the same base and I have two things that are multiplied by each other and I have two exponents on those things, remember that this is kind of like x times x times x, and then x to the 4 is like x times x times x times x. And if I kind of think about what these brackets mean, it just means multiply, right? Well, then this would mean x times x times x 1, 2, 3, 4, 5, 6, 7 times. So x to the 7. So we add the exponents when it is a, my camera's not doing so good there, when it is when the same bases and we're multiplying. So that's just kind of the reason why. Let's keep going here. This time I have an exponent on an exponent. So I have x to the 4 times x to the 4. Well, in that case, we multiply. So let's put a dot instead so it doesn't look like an x. We multiply x to the 8. Because it's like 4x's times 4x's. Well, that means 8x's. Similarly here, this is dividing, so we end up subtracting. So x to the 12. You know that. Now here's a bunch of, just a space for a bunch of really common exponents. They're good to know. The 2's are especially good to know because we're going to use 2 a lot. 4 is kind of a part of 2, and then some of these other ones, you know, it's handy to have, but it's not super necessary. So 2, 4, 8, 16, yada yada. You can fill these in. We won't waste our time on it. Now here's the good stuff. This is where it gets good. Here's a really important note that we're going to use a lot to move forward here. If I have two things that are equal to each other and they have the same base but different exponents, then my exponents have to be equal to each other because these terms are equal to each other and they have the same base. If they had different bases, well then totally different story. But the base, which is the c part, are the same, then my exponents have to be equal to each other. So here's where this comes into play here. If I have 3 to the x plus 2 equals 3 to the 7, my bases are the same, then x plus 2 must equal 7, or else these two things are not equal to each other. And if these two things are equal to each other, then I guess I could say x equals 5. And I could substitute that back in and prove it to myself pretty quickly, right? All right, so let's use that, and let's go a little harder now. 2 to the x plus 1 equals 32. Now, 32 kind of has an exponent of 1, right? But my bases are different. So that means that I can't really deal with that, except that I can recognize that 32 could have a base of 2. So let me think back to here, which I didn't even finish. 1632 would have been my next one here. 2 to the 5 equals 32. Alright, that's helpful. So I could say instead of 32, I'm going to call this 2 to the 5. And then my left-hand side is 2 to the x plus 1. Now I have the same base. Since I have the same base, x plus 1 must equal 5. Or else this isn't a true statement. And then this is easy now, x equals 4. So the name of the game here is to make the bases the same. In the future, we'll have a way to deal with it if the bases aren't the same. But for now, pretty simple algebra to make the bases the same and then look at how the exponents work. Let's try a slightly harder one here. 3 to the, my camera's not doing great here. 3 to the 4x minus 1 equals 27 to the 2x. So that already has a bit of exponent on it. I'm going to have to keep that in mind. I'm looking at the bases, 3 and 27, and I think 27 could have a base of 3. I think 27 equals 3 cubed, 27, 9, 20, yeah, there we go, 3 cubed. So instead of writing 27, I'm going to write 3 cubed, but then it also has the exponent 2x. That's a 2 right there. On the left-hand side, that didn't change, 4x minus 1. And now let's use our exponent laws. This is an exponent on an exponent, so we multiply. So that is base of 3. 3 times 2x is 6x. And then on the left-hand side, that really didn't change at all, did it? All right. Now for this to be true, that means these exponents have to be equal to each other. So 4x minus 1 equals 6x. Let's find what x is. I'm going to subtract 4x from both sides. I get negative 1 equals 2x. Divide both sides by 2. X equals negative 1/2. And if I wanted to, I should be able to substitute this back in, and find that these two values are the same. Or else something has gone wrong. Let's keep going here. All right, this part has 3 different bases, but since I've been doing these quite a bit at this point, I can tell that they could all have the same base of 3. That would be 3 cubed. That one's 3 to the 4, I believe. So let's deal with that. 3 to the x, 3 cubed, 3 to the 4, and I usually just leave it in brackets for a second until I decide what to do with it. So I'm just straight up substituting 3 to the 4 for 81, and then that 2x minus 1 is just an exponent on the outside. Now let's clean up the left-hand side a bit. These are 2 bases that are being multiplied by each other. That means we add the exponents. So 3 to the x plus 3. This is an exponent on an exponent, so we multiply 3 to the 8x minus 4. Now because the bases are the same, that means those exponents must be equal to each other. And now we can solve for x. Let's subtract x from both sides. My husband slamming a door. Add 4 to both sides. Divide by 7. X equals 1, which I should be able to prove to myself if I were to substitute it back in. Awesome. I think we're on our way here. This is a great time to pause and try the next ones on your own. We've got 3 more quick algebra ones, and then we're going to try this graphically as well, just to kind of bring it all back together. Let's try this guy right here. Looks interesting. 4 to the x plus 1 equals 2 to the x root 2. All right, we haven't quite seen this yet, but it's the exact same ideas as before. 4 could be written as a base of 2 squared, x plus 1. You'll notice we'll have this exponent on exponent quite a bit, right? 2 to the x, that's not interesting. Root x. Remember, another way to write that would be 2 to the 1/2. Or if it was a cube root, like there was a tiny little 3, it'd be 2 to the 1/3. 2 to the 1/2 right there. All right, so this is multiplying. I'm going to skip right to it this time. 2x plus 1 equals, and then addition. So 2x plus 2 equals x plus half. Subtract x from both sides. Subtract 2 from both sides. Negative 2 plus half, negative, oh boy, 3 over 2. There we go. So really, same idea. It's kind of a new little thing thrown in there, this guy right here. But we've seen that before, even if it takes us a minute to remember it. Okay, here's another one that we have seen before, but perhaps it'll take us a minute. 1 over 3 to the x minus 1 equals 81. Reminder, this is a good one to remember because it comes up a few times. Let's say I had 2 to the negative 2. Let's make a negative 3. The negative part makes it a reciprocal, so 1 over 2 to the positive 3. So we use that negative to say 1 over something. And then that would be 2 to the 3 is 8, so that'd be 1 over 8. We can use that here as well. by kind of going backwards. So if the exponent here is kind of positive, to make it not 1 over 3, we could say that this is 3 to the negative x minus 1, where we have to make each part negative. Okay, and then 3 to the 81, let's see, I can't remember what 3 to the 81 is. Sometimes I use my fingers to count it out, but you know, that's not that really, it's not that effective. 3 to the 4. Now that I have the same base, I can say negative x minus 1 equals 4. Multiply that out real quick. Subtract 1 from both sides. X equals negative 3. Beautiful. And I should be able to plug these back in and double check it, right? All right, last one. Let's finish her off here. All right, now I have a negative that is on my base. So I'm just going to keep track of that. It is not the same as this reciprocal business. That negative is on the base itself. It's not on the exponent. But let's go ahead and think about what 8 could be as a base of 2. That'd be 2 cubed. Now, this is a negative value, right? Because this is 8, and it is a negative. So I put the negative out front. And then I'm going to put the exponent on it here, this other exponent, 5 over 3. Okay, so we can see how that's the same thing there. Now these other bases, K2, that didn't change. Maybe I'll just put a 1 on it so we can see it. Times 2 squared to the x over 2. All right, let's clean this up a bit. So exponent, we multiply, so that's negative 2 to the, that's like 3 over 1. 5 times 3 is 15, divided by 3 is 5, so negative 2 to the 5. Let's see here, we're going to have to multiply this as well. That's 2 over 1, so that is just x. So negative 2 to the 5 equals 2 to the x plus 1. Now here's a problem. My bases look the same because that's a 2 and that's a 2. But this base is actually a negative 2. That is a negative value. So because there's one negative 1 and one positive 1, we say there are no solutions to this. These bases are not the same. And there's a note down here. We cannot yet solve that. In the future, we'll learn some tools, but at this point, no. Alrighty, one more. We're going to graph it now, just to bring it full circle with what we've done in the past. Solve the following equation graphically. As we have done in the previous units, we're going to graph two separate functions, and then we will find the intersection of the 2 points. So here is one function on the left, here is the other function on the right, and that's just stated exactly down here. I'm going to use pencil. Actually, you know what? I'm going to do this one first. I'm going to do this one in blue, because I could probably do that one without messing up. Y equals 5. That is a horizontal line. We've done this a lot, right? Throw some arrows on it, throw a label on it, y equals 5. Beautiful. Now let's try and graph this one. I'm going to do this one in pencil because I have a bad habit of messing it up and then trying to go backwards with pencil. Alright, let's look at what each transformation means. So within my exponent here, I have a negative 1, which just works just like all the other exponents we have dealt with that are on the x. That is a horizontal shift, and it is to the right. So I'm just going to write down right 1. That's just a little note for myself. This is a vertical shift up 2. Exactly the same as we've done in the past, right? Alrighty. And then I want to also think about that 3, because that 3 means on the original, so on y equals 3 to the x. A point would have been 1, 3. When x is 1, y is 3. So that's a good point for me to notice. On this original graph, I also would have been able to look at 0, 1. That also would have been a point on my original. So I usually think about those points first, and then I put them through the transformations, and then I'm able to draw it. So if 0, 1 would have been a point, but I'm going to go to the right one, and I'm going to go up 2, here is a point on my graph. 1, 3 would have been a point. Okay, it would have been there, but right one up to right there. Okay, I usually try to think of one other point onto the left here. So it would have been when x is -1. Let's think about what a -1 in there would be. That's 3 to the -1, which is 1 over 3. So -1, 1 over 3. These are all on this original graph. So kind of around here would have been a point, but I'm going to go to the right one up to right around there would be another point. And that's certainly enough for me to see the shape now, isn't it? So then we can draw a line through it. Be cognizant of that would be my asymptote right there. +2 would be my asymptote. Throw another arrow. Make sure we have a label. And I think I can see my solution point right there. It's where my two lines cross. I should probably just give it a label real quick. 2, 5. So my solution, we're just looking at x values here because notice there are no y values in our question. X equals 2 is my answer to this question. They also asked me to do it algebraically, so let's do this down here algebraically real quick. I'm just going to write down the question because I like it when it's written down. All right, let's isolate this exponent term right here. So let's move the 2 to the left-hand side. So -2 from both sides. And this is really handy because guess what? The bases are already the same. What's the exponent on 3 here? It's a 1, right? It's not a 0 because 3 to the 0 would be 1. 3 to the 1 is 3, which is what I wanted. So then my exponents are the same. That means 1 equals x minus 1. Add 1 to both sides. Oops, that's a 2. X equals 2. Done. And that matches what I thought it would be, right? So give this a shot. Try some homework questions and just solve them. I don't think you need to verify them or whatever else I was asking you to do. Give it a shot. Let's see how it goes. And have a good night.